Hi everyone, Mr. Diller here. Chapter 2 of the Friedland book, 2nd edition. Chapter 2 contains material that I think most of you have probably had some exposure to. So take the time to read that chapter and review and let me know if you have any questions. I do want to stop on a couple of items in here just for a couple minutes. The first is the pH scale, and it's important to recognize when we talk about the pH scale that a number somewhere around 7 represents a neutral pH. The higher the number, the more basic, and the lower the number, the more acidic. So if you see a number on the pH scale of 2, that is considered pretty acidic. Take a look here at the laws of thermodynamics, and if we start with the first one, this is again probably something that you've heard in the past, but the idea is that energy, and by the way, matter and mass, but energy in the universe is constant. Energy is never created nor destroyed. It can change forms, but it's never created nor destroyed. The second law states that when the energy transfer takes place, the amount of energy remains the same, but the usefulness of that energy may be diminished. Okay, so an example, when we take a power plant and we convert coal or natural gas energy into the production of light, there are inefficiencies. In particular, in the old days, when I was a kid, we would use these incandescent bulbs. And these incandescent bulbs produced great light, but they also got really, really hot. That heat is an indicator of the inefficiency in that energy transfer. And they get so hot that perhaps some of you, even as kids, had an easy bake oven. You can actually bake brownies with an incandescent light bulb. Later, we switched mostly to fluorescent bulbs, like the ones we have in our classroom. Those are much more efficient than an incandescent bulb, but still relatively inefficient compared to the most modern type of lighting, which is LED lights. LED lights are amazingly efficient, and if you ever touch one, they don't feel hot at all. And that's really the direction we're going with lighting. Because of that, it's a more efficient product. These closed and open systems are important. An open system, like if we take planet Earth in relation to energy, we have energy that we produce on planet Earth, but there's also inputs from the sun. And that sun is considered to be outside of our system. So that's considered an open system because there's energy input from outside of the Earth. A closed system relative to Earth would be one that considers the inputs of matter. The amount of mass or matter on planet Earth is constant, and we don't lose matter, we don't gain matter, minus perhaps an occasional meteorite. A system is said to be in steady state when the inputs equal the outputs. In this particular example, the faucet is adding water to the bucket. There's holes in the buckets and the same amount of water is flowing out. This negative and positive feedback loop is kind of important. A negative feedback loop basically just returns the loop back to its starting place. So you have a scenario, an event happens, and that event essentially takes it right back to the original scenario. A positive feedback loop is the opposite. You have a scenario, an event occurs, that event causes the scenario to increase, which causes an event to occur, which causes the scenario to increase, and you have this feedback loop that continues to add more and more to the original scenario. This is an easy example of a positive feedback loop applied to population. Another one that we see a lot in environmental science relates to climate change. If you take the example of the polar ice caps today, the reflectivity of the ice is important because it reflects solar radiation. when those ice caps start to melt, more solar radiation is absorbed by planet Earth, which heats the atmosphere, which melts additional polar ice caps, which causes more solar radiation to be absorbed, which in turn heats the atmosphere, which melts additional polar ice caps, and so on and so forth. So the reduction of the polar ice caps causes an event, the heating of the atmosphere, which then causes the original scenario, the melting of the polar ice caps, to increase even further. That's a positive feedback loop. And that, my friends, is pretty much it for Chapter 2. Nice, easy chapter and pretty quick. Let me know if you have any questions. Stop recording.